We're using the dual directional coupler provided with the system. We have measured the forward power as minus 55.6 dB. We have reversed the ports and now we are ready to measure the reflected power at this port. Now we've connected a SMA male to male adapter here so that we can begin taking the measurements of the reflected power for S parameter measurements of different devices being provided. We have provided with open stub, which is open circuited microstrip line which resonates at 1.5 gigahertz. This microstrip line has a width which is for the given substrate, and the given substrate height has a characteristic impedance of 50 ohms, which is required for minimum VSWR and optimum transmission characteristics. The stubs have a characteristic that they are able to reverse the impedance at the opposing ends. This stub has a total electrical length of lambda by 4, which is 90 degree, which means that the open stub, which is open circuit transmission line at this end, will reflect as a short circuit at this particular connector at the frequency of 1.5 gigahertz. These can be used for making the matching circuitry at different circuits. Now the short circuit stub provided has got a short which shorts this microstrip line to the ground plane at the back of the substrate. The substrate has a uniform ground plane which is connected to the ground plane of the SMA connector. Now this short will also at 1.5 gigahertz appear as open at 1.5 gigahertz SMA connector. We have provided with a VSWR equal to 3 load, which means we have put a 150 ohms connector at the end of the transmission line. This 150 ohms load with a characteristic impedance of 50 ohms system will appear as VSWR 3 or return loss 6 dB when we are taking the S parameter measurements. We have also provided with a 50 ohm match termination, which is a 50 ohm terminated to the ground at the end of a characteristic impedance 50 ohm transmission line. Now we will start taking the measurements. The forward power was 55.6 dB, and now we'll try to measure the return loss or the S11 for this matched load. This matched load is showing a reflected power of minus 67.4 dB, which means that the S parameter for this particular device is 12 dBm. So 12 dB. I'm sorry. Now we'll replace this matched load with an open stub. We'll observe that the open stub will appear as infinite VSWR, hence the return loss will be almost zero for this open stub. We connected the open stub and we see that the return loss is in the range of 1 dB, which shows that the VSWR is very high when using an open stub at 1500 megahertz. The same is the case with a short stub. The short stub is also with a minus 55.6 dB. It's also less than about 0.5 or about 0.1 dB is the return loss, which is a very high VSWR for a short stub. Now we will connect the VSWR 3 load here. As you can see, the forward power was minus 55.6 dBm and the reflected power or the reverse power is minus 60.8, so about 6 dB is the return loss, which shows that the VSWR is 3 for this given load. So our S parameter measurement system is in order, and we can begin taking the measurements for different devices under test.